Good evening, ladies and gentlemen. So this is the worksheet that we're going to come up with the key for 4.3 Practice A. This should help us for the retake quiz tomorrow. Let's get started on it. This particular worksheet should not be too awful bad. So here are the first 6 problems. Using the diagram given, name the included angle between the pair of sides given. If I'm looking just at number 1, segment MT and segment TR. MT, this segment, and TR. The angle between those two segments would be angle MTR. I think that's fairly straightforward. In like manner, moving right along, if I look at segment TQ and segment RT, the angle between those two segments is going to be this angle right there, and I can name that angle RTQ. Note that I could also name that angle QTR. This is fairly straightforward. Again, moving right along. On number 3, RT. Let's go RT and MR. So the angle included, or the angle between RT and MR, is angle MRT. I think I'm going to jump to the next problems. I have the answers for 4, 5, and 6. I will let you work those out on your own. So let's moving right along and look at these. This is something that we did from the very get-go a couple weeks ago when we started congruent triangles. This also is very straightforward. For each pair of congruent triangles, name the pairs of corresponding sides. Starting with number 7. If I have triangle ABC is congruent to triangle TDF, what I know then is that AB is congruent to TD, BC is congruent to DF, and AC is congruent to TF. And you can kind of AB, TD, BC, DF, and I can look at AC and TF. This again is very straightforward. I will let you take a look at number 8 and 9 on your own. Triangle DCT, triangle FLG. DC is congruent to FL. CT is congruent to LG. And DT is congruent to FG. Very straightforward. And here's the answer to number 9. I'm not going over number 9. You can pause the video and check your answer. Let's get on to a couple more problems. At this stage in the game, 4.3, we had only discussed 2 congruence theorems, 2 ways to prove triangle congruent. We had discussed side, 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 and side, angle, side. So the question on number 13, the question was 413. If we go back to our original diagram, I didn't get that scanned in there. Here's what number 13 was asking. Oh, I went a step too far. So what we want to do for 10, 11, and 12, 13, 14, and 15 is decide whether there is enough information to prove the triangles are congruent. If there is enough information, state the congruence postulate that you would use. So let's find the slide that has number 10 on it. And right here we are. This is number 10. XYW and ZWY. So I want to determine if I can prove that XYW, that triangle, is congruent to ZWY. And I believe I can. Here I have these two sides are congruent by the congruent dashes, and these sides are congruent, again, by the congruent dashes. Oh, so I only have two pairs of congruent sides. Congruent. Wait for it, and they both share this side in the middle, which is WY or YW. So yes, indeed, I can prove these two triangles are congruent by the side congruence theorem. Number 11 seems to trip some students up, because it's certainly the reason why this problem is going to trip you up, because those two triangles certainly look congruent. MAE looks congruent to TAE. MAE, this triangle really looks like it is congruent to TAE. But I can only prove those triangles congruent by one of those four congruent statements. And note, at this stage in the game, I had only learned two congruent statements. Side, 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 and side, angle, side. So even though they appear to be congruent, I don't think we can prove they're congruent. Because all we have these angles congruent. M is congruent to T. And I do have ME congruent to TE. I do have these two segments congruent. Oh, and I do have, they both share this side AE. But angle, side, side, because that's what we have. We have angle, side, side. This is not a congruence theorem. So I cannot prove those two triangles are congruent. And note what the question was asking. Is there enough information to prove the triangles are congruent? And no, we do not. Angle, side, side is not a congruence theorem. So let's go to number 12. And I think number 12 is fairly straightforward. I have KHJ is triangle, KHJ, congruent to triangle KLJ. Let's see what we have. Oh, we have KH congruent to KL, good deal. And I do have that angle JKL is congruent to angle JKH, good deal. And they do indeed share a side, KJ. And if I look, this fits one of the congruence theorems that we've talked about. Side, pair of corresponding sides congruent, pair of corresponding angles congruent, and another pair of corresponding sides congruent. So these are congruent by the side, angle, side theorem. So 10 we have a yes, 11 we have a no, and at 12 we have a yes. Moving right along with 13, we have is triangle DKA congruent to triangle TKS? Is triangle DKA congruent to TKS? Let's examine it. I'm thinking that it is a yes. And we do have DK. Let's see here. We do have DK congruent to TK. Nice. And I do have, oh, this is handy. I do have that angle DKA is congruent to angle TKS because of vertical angles, that's true. And I also have segment KA congruent to segment KS because of the congruent dashes given in the diagram. So here I have a pair of corresponding sides congruent, a pair of corresponding angles congruent, another pair of corresponding sides congruent, and this fits the side angle side congruence theorem. I don't believe that I can prove, talking about number 14, I don't believe that I can prove that these triangles ENV and LOV are congruent. Again, it appears that they are, but we don't have a side-side angle congruent statement. We do have NEN congruent to LO, and we do have NV congruent to OV. Oh, and in the diagram, they tell us these angles are congruent. But if I look closely, I have a pair of corresponding sides congruent. I have another pair of corresponding sides congruent. And I have a pair of corresponding angles congruent. But side-side angle is not a congruence theorem. So this is a no. Note that thus far, we only discuss side, 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 and side, angle, side. Later on, in the next section, which will be the next topic we did, and we have done this, we talked about angle side as being a congruence theorem. And we talked about angle side angle. Those are our only 4 congruence theorems that I can use to prove 2 triangles congruent. So side, side, angle is not one of them. I think 15, moving forward, I think 15 is a fairly straightforward problem. And if you look closely, you will see that we can use side, side, side on this particular problem. Let's do the small proof for number 16 on this particular handout. Complete the proof by supplying the reason. I think on the quiz tomorrow, I will have you come up with the statement and the reasons, as we did on the prior quiz. And the proof that I will ask you to do tomorrow will be similar to this type of proof. So here's our given information. I know I am given that O is the midpoint of MQ, and O is the midpoint of NP. And they have this diagrammed out for me in the, let me erase that, that kind of got in the way. They have this diagrammed out, these 2 statements. Because if I look at this statement, this particular segment, and I know that MO is congruent to QO, that makes O has to be the midpoint. That's given. And this is going to be the first line in my proof. O is the midpoint of MQ. That particular statement is given. And what does that tell me? Because keep in mind, I want to prove segments congruent or corresponding angles congruent. What does this tell me? Well, this tells me that I'm going to get my pen to work here. This tells me that MO is congruent to QO. Why? This is the definition of midpoint. I go with my second given statement. O is the midpoint of NP. Again, this is given in the diagram by those congruent slashes. O is the midpoint of NP. What can I tell from that? I can certainly say that NO is congruent, segment NO is congruent to segment PO. Why? Again, because of the definition of midpoint. So if I look here, thinking about my strategy, I have two pairs of congruent sides congruent. Oh, and I also have the included angle congruent of those two pairs of congruent corresponding sides. And those two angles are congruent. Why? Because of the property of vertical angles. So let's make that statement. Angle NON, MON, is congruent to QOP. Why? Because of the property of vertical angles. Now, I think it's going to be fairly clear that I can make the statement that that triangle MDH is congruent to triangle QOP. Why? Because I have side angle included and another side. If I were to write these steps out, I would write this particular guy first, this one second, and this third, because then it's going to be easier to see that I'm using side, angle, side to prove those triangles congruent. This is going to be the end of the key this is the key that we want to study for the retake quiz tomorrow. This is the key for the 4.3 handout.